Good evening to all. Welcome to this session on ESE 2024. I am Dr. Chakrapani. I am here with all eminent professors of ESE Engineering Academy. The question paper is given with equal weightage for all the subjects. We will see it in soon. And we are here to discuss all the questions and give the solutions and also the key. We will start one by one. Thank you.
All the best.
Yeah, let's look at the number of questions appeared in each subject in ESE 2024. The total number of questions are 150, and this is the number of questions in each subject. You can see almost all the subjects have got equal weightage. So we are going to discuss all the subject questions one by one, and you are going to see what is the key for those questions. I request my colleague to come and start the discussion on the questions. Thank you.
Hello everyone. So this year ESE we got around 11 questions on signals. Let us see the models. A continuous signal is sampled at the rate of 10 samples per second. What is the ROC of jet transform of the respective discrete signal? First you have to convert the continuous signal to discrete signal. Sampling rate is mentioned as 10 samples per second. So find out TS, 1 over Fs, that is 0.1 seconds. Take the discrete form x of nt, that is x of 0.1. When you substitute minus 2 into e power minus 3, t place we are substituting that is 0.3n, 3 e power minus 0.4. Standard jet transform we are aware, a power n un jet transform. Take the jet transform. So for the first term minus 2 by 1 minus e power minus 0.3 z inverse. Second term 3 by. So look for which is the largest pole because we are expecting the ROC. Of course here you may need calculator, but according to the given options 0.67, 0.74 which is the largest pole we have. As it is a right side sequence, option D is the best one. Okay, very simple model. Matched jet transform, generally we will discuss IIT and BLT, impulse invariant and bilinear. Matched jet transform in a transfer function, it will map separately poles and zeros from S plane to jet plane. So out of the given options, which contains that poles and zeros? Non-recursive, no feedback, that is FIR, elimination of the option. Option C also can be eliminated because the word all pole filter is used. Recursive filter, they can be implemented in both ways. So the only possible option is inverse Chebyshev because it contains both poles and zeros. That is the beauty of MJT, matched jet transform method. It can map both poles and zeros from S plane to jet plane. 40th question, which of the given statements are correct? First one, everyone aware, band pass sampling standard condition. Second statement is, it is true. If we sample at a rate higher than twice the highest frequencies, aliases can be eliminated. That is also true. The absolute minimum sampling rate is most favorable situation, that is twice the highest frequency, not the bandwidth. It depends on whether it is band limited signal or for band pass signal. So the best option here is 1, 2, 3 are correct. Maybe 1 and 2 also. Maybe 1 and 2 also, depending on whether it is band limited or band pass signal. So if you feel band limited, you can feel 1, 2, 3. But for the first statement is given for band pass signal. Recursive system described by linear constant coefficient difference equation. The word constant coefficients is given means time invariant system. Already hint is provided, it is linear. So automatically which is the correct option? Linear time invariant system. Very simple one. This is framed wrongly in the options. Output contains certain number of samples. Input system also contains certain number of samples. So you have to get the input. So output length is m plus n minus 1 samples. Based on that length is here 5 samples. System length is 3 samples. If you feel like n, that is 3 samples. If you solve for m, it must be 3 samples. So we have to assume the unknown samples like ABC. System data is given as 1 to 1. So take the product A, B, C, 2A, 2B, 2C, then A, B, C. Just we are comparing the output. What are the output numbers given? 1, 5, 10, 11, 8. All the given options are wrong. Because what is the last number? C equals to 8. We got no option have that answer. So all the given options are wrong. By comparison, what is the last value we got? C equals to 8. So all options are wrong in this particular question. The convolution sum is valid. You are aware it is strictly valid for LTI systems only. We are writing xn convolved hn standard relation sigma xk h of n minus k. Only for LTI systems the convolution sum is valid. That is linear time invariant systems. Linear time invariant systems. Okay. If xn is a periodic signal having fundamental period t and takes infinite values, means after sketching one period of the signal, the data is go on repeating for every Kaplan samples. As you are aware, all periodic signals are power signals, and of course the power in the periodic signal is calculated only for one cycle automatically, which is the correct one. All periodic signals are power signals, and it is valid only for power signals. That is a valid option, power signals only. This is one of the finest question. So when you have a difference equation something like this and you want to apply the input like 2 power n alpha power n form, what is the respect to particular response answer? Okay. When you apply the input of the form alpha power n, the equivalent output must be like k into alpha power n form. What is the input mentioned here? 2 power n. Directly you have to substitute the data in the given difference equation and solve. So you are assuming the output like this form, k into alpha power n, 5 by 6 into, what is that alpha mentioned for us? Input form we already know, 2 power n, that you have to substitute there. K into alpha power n, 5 by 6, alpha power n minus 1, minus 1 by 6, alpha power n minus 2, plus input is given as 2 power. If you solve for k by eliminating the unnecessary multipliers, don't check that mathematics now, you are going to get the answer 8 by 5 into 2 power. Just you have to get this logic. If the input is alpha power n, output is k into alpha power n form, standard form, substitute and solve for k, you are going to get the answer. Very simple. The cross correlation. You are aware, cross correlation means convolving one signal with folded version of, so x of n data as it is 1 to 1 1, and take the flipped form of the other signal, that is also 1 to 1 1. If you flip it, this is yn, you have to flip the data and enjoy that convolution as usual by one of your own method. It is going to produce the answer like 1466, last option. Very simple, normal sum by column method. Okay. This one, which of the following statements are correct? Impulse is even function, true. This is wrong. Scaling property of impulse are also we are aware. So which of the given statements are correct means only 1 and 3. Impulse is even function and scaling property both are valid. Maybe in hurry they have prepared the paper. If you see this particular question, impulse response 3 power and un indicates a non-causal system, but it is causal. This original system is causal. Cos n pi by 2 is non-causal, but it is stated as causal. E power minus 5 mod n, it is a two-sided function, that is non-causal. So which of the above statements are not correct? They have given indirectly, but 1, 2, 3 options are not available. So this is also with respect to options, it is wrong, because we know the nature of the signal. So these are some funny models we got this year, all very easy questions. Okay, I am handing over to the next faculty member, Mr. JNR sir, control system. He will come. Thank you. in control system 10 questions are came. So all are easy questions. The first one, the open loop transfer function of a system they given g of s equal to 10 divided by s into 1 plus 0.1 s given, and is asking acceleration error constant Ka equal to limit s tends to 0 s square into g of s. If you solve it, 10 divided by s into 1 plus 0.1 s. So if 1 s cancel, if s tends to 0 substitute, you will get the 0. And similarly solve it kV, velocity error constant also asked velocity. Kv equal to limit s tends to 0 s into g of s. What is g of s? 10 divided by s into 1 plus 0.1 s. SS cancel, then s tends to 0 means you will get the 10. And next asked position error constant Kp, limit s tends to 0 g of s. So if you solve it, you will get it here infinity. So option C is correct. Next here is asking the range of k, maximum value of k is asking, that is nothing but k marginal. So characteristic equation is s cube plus 5s square plus 9s plus k minus ks equal to 0. So that means s cube plus 5s square plus s 9 minus 5s square plus 9 minus k plus k equal to 0. So if you write a Routh tabular form, s cube, s square, s power 1, s power 0, 1, 9 minus k, and here 5, k, 45 minus 5k, 45 minus 5k minus k divided by 5, here k. Then you solve it here, this should be make equal to 0. So you will solve it, you will get the answer is 7.5 around. So 45 minus 6 k equal to 0, k equal to 45 by 6. You will get it. Next one. So here unity feedback system they given, damping ratio zeta 0.5 they given. They are asking the time to peak and TP they are asking, that is pi by omega d. So characteristic equation is s square plus 10s plus k equal to 0, 2 zeta omega n equal to 10, then omega n equal to 10. So we don't need omega n. You find Tp. So what is Tp? Pi by omega d. So if you find omega d, you will get 8.66 you will get. The answer you will get 0.363. Next one here, consider the following statement. Rise time for underdamped is 0 to 100%. TR is 0% to 100%. But here given what? So 5 to 95% means first one is wrong. And the amount of maximum overshoot directly in the relative stability, it is 100% correct. Settling time is, it is 2% and 5%, that means third one is wrong. Which of the statements are wrong means 1 and 3 are wrong. Next one, consider the following statements. In PD controller derivative action, this first one is correct. And the second one, PI controller, it is wrong. And here PI control system has some oscillator effect, it is correct. Which of the following means 1 and 3 are correct. Next here it is a very big question, but it is unstable with 2 poles in the right, option D, it is correct. Next, range of k, simply characteristic equation is s cube plus 3s square plus 2s plus k equal to 0. So simply internal product 6, external product k, simply k greater than 0, less than 6, system is stable, option C.
Next here the breakpoints they asked it simply d by ds of the given system, that is s plus 2 divided by s plus 1 whole square equal to 0. U dash means 1 into s plus 1 whole square minus u means s plus 2 into v dash means 2 into s plus 1 equal to 0. So you take s plus 1 common, then you will get here s plus 1 minus 2 s minus 4. So equal to 0. You solve it, you will get s equal to minus 1 minus 3. Answer D correct. So which of the following related to the, here all are wrong only, because here when you draw the Bordeaux plot, the initial slope is minus 40 dB for a decade and intersect here at omega, that is telling omega x. Actually this will become, k will become omega x square, means first one wrong, and even second one also wrong. He is asking the magnitude at omega equal to 1. The magnitude at omega equal to 1, if you find it, the magnitude at omega equal to 1 you find, you will get 20 log k you will get, not 40 log k. Second one also wrong, and third one also wrong, because the k will become the acceleration error coefficient, that is because it is a type 2 system. So third one also wrong. So all are wrong only here, no option matches. Next, gain margin gives the what? Closeness of the what? Minus 1, critical point. So that will give the gain margin. First one is correct. Second, phase crossover frequency, not the negative real axis, it is a positive real axis. Second one is wrong. And here phase crossover frequency is minus 180. So third one is wrong. That means 2 and 3 are wrong. So which of the following are not correct means D, 2 and 3. That's all. Next my colleague will continue.
Right. Now let us see the questions given in digital communication, analog communication as well as advanced communication in today's paper. Let us go through all the questions one by one. Pretty simple only, nothing very difficult. Which of the following mid-band frequency of IF section is used? So IF frequency which we use in FM is 10.7 megahertz. So direct bit. There is nothing that you need to do. Simply go with the answer. Okay. Very simple question. Next. Consider the following statements. So he has given 3 statements related to amplitude modulation schemes. First one, DSB, SSB and VSB are linear modulation schemes, correct. All amplitude modulation schemes comes under linear schemes. DSB is used for point-to-point communication, absolutely correct, we can use, no problem, because you have transmitter and receiver, you can use for point-to-point communication. SSB modulation scheme is less affected by frequency selective fading. This is also true, because when compared with standard AM or DSB, fading is less in case of SSB modulation scheme. So for this one, you can go with all the 3 options, 1, 2 and 3 all are correct. Let us see the next question. Which of the following schemes is used for transmission of video signal in commercial television broadcasting? Standard bit, vestigial sideband modulation. Next, see the data here. He has given as a numerical. High resolution black and white TV picture consists of these many number of picture elements, 2 into 10 to the power of 6. And 16 different brightness levels. 16 different brightness levels means the entropy or the number of bits you require per level will become automatically 4. Don't write that 16 again. Directly 2 to the power of 4, 4 log that value will become 4 log 16 to the base 2. And they are repeated at 32 bits per second. So that means sampling rate. So the total value whatever you are getting is nothing but bit rate. That is what he is asking. So the average rate of information source is dash. So if you multiply this, you will get a 256 megabits per second. So that would be your right choice. Okay. So your information content is present here, 16 different levels. That if you identify, that is done. Next, let us go to the next question. See here, this is also a numerical based on FM systems. Carrier is frequency modulated with a single tone signal. So your frequency of message signal is 2K and maximum frequency deviation means delta F max is 5K. So straightforward the value of beta delta F max by F max will become 2.5. Because it is greater than 1, it is wideband FM. Confirm. Now what is he asking? What is the bandwidth? Bandwidth is what? 2 into the value of this beta plus 1 into maximum frequency of your message signal. So 3.5 into 2 is 7, 2 is 14 kilohertz. So your right choice should be option A. Just confirm whether it is a narrowband or wideband, that is enough. You can go with that option. Next, this is theory bit. If in addition to being stationary, means already the random process is stationary. In addition to that, it is also ergodic. Means what? Whatever the statistical parameters you are calculating using a ergodic concept and the statistical parameters you are calculating using stationarity concept are same. In such case, which of the following is true? Automatically the power should be same. So only first option should be right. These are all options related with the power only. So you can go with the first statement. Next, this is based on angle modulation. In angle modulation, means it can be FM or PM, which of the following 2 factors limit the value of modulation index beta? So what is the value of modulation index beta? If you are considering a value of beta, this can be a value between 0 and 1 or it can be a value greater than 1. So your beta is basically depending on maximum value of frequency deviation and maximum frequency of your message signal. So this again depends on amplitude of your message signal if it is single tone AM and maximum frequency of the message signal which is FM. So out of these which one will be the proper choice, which is affecting the value? Obviously in bandwidth formula you will use FM and there is no other pre-emphasis, de-emphasis, these circuits will not get affected by beta. So only option that is possible here is A. You can go with option A. Next. In which of the following modulation schemes quantizer is a 1-bit quantizer? So we use 1-bit quantizer in delta modulator. You can also call it as a 1-bit DPCM. But in options that 1-bit DPCM is not given, he has given directly as a delta modulator. So you can straight away mark that option. Next, the average probability of bit error in each channel of coherent QPSK. See carefully. So what is the modulation scheme he is using? He is using 4 PSK, quadrature or 4 PSK both are same. E and N naught. So see the options carefully. Options are given in case of complementary error functions. Half ERFC of x by root 2 is your Q function, which we are writing as Q of x. That is a relation between complementary error function and Q function. So most of the times when we do numericals, we elaborate in terms of Q functions. But here he has given in terms of complementary error functions. So try to eliminate the options. So which ones you can remove directly? You can remove this operation first of all. And numerator will be our energy. So here you can see there is n naught here, so that is not possible, and there is n naught here, this is also not possible. So only possible choice will be B. Easily you can mark the option. No need to do any other research here, directly go with that case. Okay. Next, consider the following statements regarding a Gaussian process. Very good theory question. These type of questions you should be very good with concept, then only you can answer. See carefully. If a Gaussian process is wide sense stationary, then the process is not stationary in a strict sense. That means what is the meaning? He is saying a random process is already wide sense stationary. Wide sense stationary random process is there. If a Gaussian process is wide sense stationary, then the process is not stationary in strict sense. Not stationary in a strict sense. Means what is the meaning here? When you take a strict sense stationary process, it should be, if it is a second order strict sense stationary process, then it can be considered as a wide sense stationary process. That means all strict sense stationary process can be wide sense stationary, but if it is a wide sense stationary process, it need not be a strict sense stationary process. So whatever he is saying looks to be correct. Okay. Next, if the Gaussian process is applied to a stable linear filter, means he is considering an LTI system here, then the random process y of t deployed at the output is also Gaussian. Correct, because linear transformation of a Gaussian random variable will be definitely Gaussian random variable. So input is a Gaussian random process, output also will be Gaussian random process, provided your system is LTI. Now, if the random process x of t1, x of t2, so on of x of tn, you are sampling this process at these time instants, the resulting random variables are uncorrelated, that is clearly given. Okay. Now, these random variables are not stationary, they are not stationary independent. One important point we cover in class, whenever you consider Gaussian random variable, concept of uncorrelatedness and independent are same. That is applicable only for Gaussian random variable case, but here he is saying he is not applying. That means you can remove that 3. So 1 and you can remove this option 3, the only possibility is 1 and 2. So both these statements are correct. You can go with statement A. Okay. So here be careful, this second statement is little bit confusing. So Gaussian, second statement is 100% correct, no doubt, but the first statement you have to be careful. So if it is wide sense stationary, it need not be necessarily strict sense stationary, but if the process is strict sense stationary, definitely you can consider it as a wide sense stationary process. That is the meaning. Okay. So I think it is better to go with option A, where you can consider statements 1 and 2. Next, this is also definition only. He is talking about channel capacity in the first option. So this is the correct formula for channel capacity, B into log of 1 plus S by N. S represents signal power, N represents noise power. For AWGN noise, N naught into B in your message signal bandwidth is correct. Mutual information is always non-negative, H, correct, and it is always symmetric, this is also correct. Now see the last option, this relation among I of xy, h of x minus h of y plus h of x given y is wrong. This relation does not hold good. So except for all the remaining 3 statements you can go. So you can go think with the 1, 2 and 3. Okay. Is it clear? Fourth statement is wrong. You will not get that. You will get h of x plus h of y minus h of x given y. That is your information carrying capability between x and y. Okay. Right. So these are all the questions given. One more is there. Consider the following statements regarding communication system. So see the definitions given here. So he is saying baseband signal contains frequencies in the audio frequency range. So he is talking about baseband data transmission. So this is at low frequency transmission through a physical channel. So whatever he is saying is correct. Digital repeaters reconstruct the received digital data by minimizing the effect of signal attenuation and distortion. Correct, because the signal total reconstruction is possible. Digital signal can be propagated through a limited distance. No, when you convert your signal into digital model, you can transmit it to high distance because the effect of noise on the signal can be reduced. So that is the reason you can transmit it through higher distance. So you can remove 3, you can say that this 1 and 2 are correct, means option A would be correct. Okay. So these are all the questions given on communication systems. Now, the remaining questions that we are going to see are on advanced communications. Few questions came this year. Actually, advanced communication every time weightage is little high, but this time it is less. Questions are also pretty direct. See this first one, direct numerical. Cell site transmitter generates 15 dBm, decibel milli. Connected to an antenna, RF coaxial cable loss is 3 dB and the connector losses are 2 dB each, 2 connectors are there. So what is the total loss? Total loss is 3 plus 2 into 2, it becomes 7 dB. So what will be your received power? Total transmitted power 15 dBm minus the 7 dB, so it should become 8 decibel milli. Finish, over. So directly you can go with this option, option D. Okay? No need to convert the dBm into dB again, directly you can tell. Next, which of the following is a disadvantage of CDMA? Be careful. He is asking what is the disadvantage of coded division multiple access. So here it is simple to operate, that is fine. It does not require any transmission synchronization between stations. No, it requires transmission. It requires. So this option is wrong. It offers sufficient protection against interference from other stations. That is true. It has low throughput. So which of the following statement is a disadvantage of CDMA? Actually it becomes option B. So you have to go with this B. Okay. Next, which one of the following statements is correct for ST connector? So this is not from the advanced communication part. I think it came in between. No need to worry. We will just skip to the next one. Network and switching subsystem does not have which of the following switches and database. So this is also from cellular communication. Network and switching subsystem. So mobile services switching center, it will have home location, it will have visitor location also, it will have. It will not have operating and maintenance center. This will be with directly cell site. So option D. Next, which one of the following is not an advantage of wireless LAN? So what is the main problem with wireless LAN? You have to take permissions from the government. You cannot by yourself set up that station. Some formal permissions are required before setting up that system. So this is a major disadvantage. Several government and non-governmental institutions worldwide regulate the operation and restrict frequencies to minimize interference. So that will be the disadvantage. This is the last one. The critical fiber length of a fiber reinforced composite ranges from. So this is not so direct bit. Very rarely we will see these type of questions. Critical fiber length means whatever the optical fiber cable you lay, how much pressure it can take from externally so that its operation does not get affected. So there is no particular value because he did not mention the nature of the optical fiber. Generally this will be in mm. Our fibers will be in the order of micro. Diameter 2A will be in the order of micrometer. So this fiber length we require in terms of millimeter. So if you take this, generally it comes around 150 to 200 times. So I think option B would be the right choice. So these are all the questions given in communications and advanced communication in today's paper. A little bit ambiguity questions might be there, but otherwise paper is very, very simple. My next faculty, he will take the remaining part of the subject. Thank you.
Okay. So let's look at analog circuits. What are the input and output impedance respectively with feedback for current series circuit? So this is series feedback. So the input is in series form, output is also in series. So the gain A is given, input resistance is given, it's not clear, I think 15K. The output resistance is also given around 25K. Now you are asked to find the input and output resistance with feedback. So the input resistance with feedback in series is the input resistance of the basic amplifier multiplied by 1 plus AV. So it is 15K into 1 plus 200 into 25 is 50. So this is going to be around 765K or 0.765 mega. And similarly, the output resistance with feedback is output resistance of the basic amplifier multiplied by 1 plus A beta. So output resistance, it's not clear, 25K into 1 plus 50. So that is going to be 1.275 mega. 1.275 mega. Option B is the solution. Option B. So what are the values of voltage gain, input resistance, output resistance with voltage series feedback? So this is a voltage series feedback. So input is in series form and output is in shunt. A similar problem, and you are asked to find the gain also. The gain with negative feedback is A by 1 plus A beta. So how much is A given? A is minus 100 by 1 plus minus 100 into minus 0.1. So this is going to be minus 9.09. I got minus 9.09. And option D, we have option D. So input is in series. So the input resistance with feedback is the input resistance of the basic amplifier multiplied by 1 plus A beta. So same thing you do, just substitute A and beta, you get around 110K. And output resistance, since it is in shunt, divide by 1 plus A beta. So it is going to be 20K by 11, it is 1.82K. So for this problem, option D is the solution. Option D, minus 9.09, 110K and 1.82K. Now this is a simple question. The frequency of a practical FET Colpitts oscillator can be found by. So we know in a Colpitts oscillator you have one inductor and two capacitors. So the frequency is of the form 1 by 2 pi root LC. Since there are two capacitors, the examiner has mentioned C equivalent. So 1 by 2 pi C equivalent, L into C equivalent, which is option D is the solution. Next, the Q point of the BJT is selected in such a way that the gain of the BJT, generally we want the gain, you don't choose gain at the cutoff region, you will choose a gain somewhere in the active region where the characteristics is having an exponential relationship with the input. At that point, you have to apply a small signal to get a stable gain. So option A is the solution. Next, so what are the stability factors and the change in collector current respectively for the emitter bias transistor configuration with RB equal to 240K, RE is this. So I have drawn the circuit and I have calculated it. So let me draw the circuit here. RC is not given. RE is given, which is 1 kilo ohm. RB is RB 240K. You have VB here and VCC. So from the data given, I have tried to draw the circuit here. But since he mentioned collector current, what is the relationship between base current and collector current? IB is IC by 200. Since beta is 200, no, beta is 100 here. So IC by 100, and here IE is going to be 101 by 100 into IC. So a single KVL will finish the problem. VCC is going to be IC by 100 into 240K plus VB plus 101 by 100 IC into 1K. Now from this equation, we will get the solution. So what is the solution is, your IC is going to be VCC minus VB into 100 by 240 plus 101, I got 100 by 341. So now you do change in IC by change in VB. So this 100 by 101, we are getting minus 0.293. Minus 0.293, and change in VB, if you send it to the other side, change in IC with respect to temperature is minus 2.293 into change in VB by change in temperature. So this temperature change, the VB change is given minus 0.7. So 0.293 into minus 0.17, I calculated it to be around 50 micro. So option C is the answer. An amplifier without feedback has a mid-band gain of minus 1000, lower 3 dB frequency is given, upper 3 dB frequency is given. Now generally in a negative feedback structure, what happens is, if gain reduces, the bandwidth will improve. So the lower cutoff frequency with feedback can be divided by 1 plus A beta, and the upper cutoff frequency with feedback you can multiply by 1 plus A beta. So it's a simple substitution problem. So after substitution, I got, so let me substitute here. Lower cutoff frequency is given as 5K, 5K by 1 plus minus 1000 into minus 0.1. Minus 1000 and minus 1000 is given, minus 0.1 is given. So it is 49.5 hertz. And upper cutoff frequency after substitution, it's a simple substitution problem, into 1 plus A beta. It's around 101. It is 5.05 mega. So option D is the solution. So whenever there is negative feedback, there is an improvement in bandwidth. So that's the trade-off when you reduce the gain. So lower cutoff frequency will reduce and upper cutoff frequency will increase. So that's how the bandwidth has improved. And for a typical transistor amplifier, what should be VC? So this is a VC. Generally in the design, what we do is VC is going to be half of VCC. So if you want a symmetrical swing, this would be a better choice. Option D, 25 to 75% of VCC is the VC choice. This is a simple circuit. Which of the following is correct? Capacitor, the shunt arm, resistor in the series arm. So this is an ideal integrator. It's an integrating amplifier. Which of the following characteristics are essential for, see this is an, there is ambiguity in the problem. He has mentioned all the ideal characteristics and he wrote a practical op amp here. So something wrong in the question. So this is another simple question. For a fixed bias circuit, he has asked you to find this RC. So what is RC? Simply, it is VCC minus VC by IC. So just substitute here 10 minus 4 by 6 milli it is 1 kilo ohm. So this is RC, and what is RB? RB is going to be VCC minus 0.7 VB by IB. IB can be written as your IB can be written as IC by beta. Your IB can be written as IC by beta. So you can substitute and get the solution. Find the output voltage if a silicon and germanium diode. If diodes are connected in parallel, what happens is you should see that there is no violation of Kirchhoff's law. So if there has to be no violation of Kirchhoff's law, the germanium is going to get on. So this voltage I am not able to see. If my guess is correct, this is 15 volt. 15 minus 0.3, 14.7 is the solution. Okay. Now my friend will take over.
Hi. So there are many questions this time on digital as well as computer organization. We'll see one by one what is the key for that. If you want to have complete solution for the detailed solution, please type to the website, we will upload it there. So coming to this question, what is the type of adder where it is divided into number of blocks and it is going to be implemented is nothing but carry look ahead adder. For this question, answer is B. And we know the twisted ring counter is nothing but Johnson counter. And its counting capacity is 2n:1 counter. So he has given that the number of states are 10, that is 2 power n equal to n, that means n equal to 5 flip-flops. So the option for this is A. Right, going ahead. So we know that ROM is fixed and programmable OR. PLA is programmable and plus programmable OR. PAL is programmable and plus fixed OR. So if you remember these principles, it's very easy to answer to all these questions. In this one, the correct answer to this is B, that is 1 and 2 only. Okay, why the first one is wrong? Let me tell you. The reason is he told PLA is nothing but programmable at AND level and OR level. But if you see PLA, yeah, so he told that PLA, you can see both of them are programmable. But in the first statement, he told that OR array is going to be fixed one, hence it is incorrect. Coming to the second one, so the PLA is cheaper than programmable array logic. The answer is no. Why? Because if number of inputs increases, the number of inputs to the AND gates and number of inputs to the OR gates are going to increase. That's the reason this is wrong. So this one is correct and this one is correct. Hence, the correct option is B for this. Which of them is incorrect in this one? So 1 and 2 is the answer to this. Okay, this is again a simple one, same as the previous question. Using 5 flip-flops, if you build a twisted ring counter, how many states will be there? The answer is 10. It is a 2n:1 counter. It is a 2n:1 counter, hence 2 into 5, 10. Yeah, coming to this one, what are the essential prime implicants? For this, you have to see how to group them and then classify them into essential and non-essential prime implicants. Okay, so here I am going to get a quad here, pair here, another pair here, another pair here, another pair here, and another pair here. Okay, so we have to make all possible prime implicants and classify them as EPIs, and then in that case, the EPIs are going to be, this is EPI, and this one is EPI, and this one is EPI. That's it. 3 essential prime implicants are there. One of them is a quad and other one, 2 of them are pairs. So the correct option to this is the D. Okay, D is the option to this. Next, a 12-stage counter is operating a 12-stage ladder network using a reference voltage of 10 volts and the counter details have been given. If you observe carefully, this is nothing but counter type A to D converter. In counter type A to D converter, maximum conversion time is 2 power n minus 1 into T. So here n is 12. And T is 1 by 1 megahertz. So the maximum conversion time is 2 power 12 minus 1 into 1 microsecond. That is 2047 microseconds. That is 2.047 milliseconds. So the nearby answer to this is 1 minute. 4096 microseconds, that comes to 4.096 milliseconds. So the correct option is B. Okay, like this, if you just remember what is the principle, you can easily answer to these questions. Yeah, so of course, unfortunately here, it has given some memory based question. You have to know about IC number and what is its description. So this one is a 2:1 multiplexer having a quad nature. So the correct option to this is this one, 4-bit 2-input multiplexer. Fine. So here he has given an expression here, and then which of the following statements are correct? You can observe the inputs sometimes connected to C here, but in other options it is connected to A. That means you have to choose here A and B as selection lines, and you have to choose here in B and C option, D options, you have to choose B and C as selection lines. So if you choose it accordingly, first convert them into min terms. So if you convert this into min terms, it is going to become 6 and 7. This is 0, 0, 0, 0, 1, that is 1, and then 1, 0, 1, that is 5, 1, 5, 6, 7. So you have to do two things. First of all, select AB as selection line. That is going to be AB equal to 0, 0, 0, 1, 1, 0, 1, 1, and here it is C and C bar and C. So fill all the min terms here, 0, 1, 2, 3, 4, 5, 6, 7. So here you encircle the min terms. And based on this, we will come to the get C, 0, C, and this is 1. So C, 0, C and 1. Like this, it is going to match with the C option here. So the correct option to this one is C answer. Suppose if these options are not matching with the given options, then you have to choose B and C as selection lines, work out on the same procedure. That's what you have to do. But luckily, with AB selection line, the answer is matching. As it is only one answer, you can end up the procedure here. Fine. It's come with respect to the Moore model. Okay. So Moore model sequence circuit is called as transition assigned circuit. No. Okay. Because it is going to have the output related to present state only. It is not based on transition. Next one. In Mealy model sequence circuit, output is associated with the state transitions, that is the arcs in the state. It is correct. In Moore model sequential circuit, outputs are the functions of both the inputs and the present state. Wrong. Because in Moore model, output depends only on present state without depending on the input. So what did he ask you? Which of the above statements are not correct? That means the first one is only not, first one and third one is not correct. 1 and 3 only. So this is the answer to this. Second one is correct statement. First and third one incorrect. So the correct answer is B. Yes. So consider the following statements. A PAL comprises of programmable and an OR array. Correct. Unlike PROM, in which all 2n possible products of n variables are generated, a PAL contains only limited number of product terms. That is the main feature of that. Read-only memory main disadvantage is it produces all the min terms whether it is required or not. That is non-essential. Hence we go for the PAL. Okay. The overall cost of PAL is considerably lower than that of comparable PROMs and FPLS. This is also true. So what is asking? Which of the above statements are correct? 1, 2 and 3, all of them are correct. So the correct answer is D. So like this, if you just know the basics and having a presence of mind, you can easily answer to these questions. But you should not be in a hurry to answer to this. Okay. Fine. Next one is, consider this one here. In a gated SR latch, for S equal to 0, R equal to 0, the latch output does not change. Correct. In a JK flip-flop, when J is 1 and K is 0, enable pin is 0, all the flip-flops will be reset. Correct. latches and flip-flops both are basically bistable elements. This is also correct. So which of the above statements are correct? So in the given options, the correct answer to this is C. First, second and third statement, all of them are correct. Okay. So this is a serial in, serial out shift register. Fine. So in order to get to the value of 1110, how many number of clock pulses you require? So you know very well. Now you give input of 1, apply first clock pulse, it comes like this. Next give input of 2 and apply second clock pulse, it comes like this. Give another input of 1 and apply the inputs, it is going to come this. So to reach to the value of 1110, it requires 3 clock pulses. That is the correct answer to this. B is the right answer because a serial in, serial out shift register will follow this type of description. Okay. Now coming to the multiplexer again, a routine problem, but here a small ambiguity. Here the selection lines are given as BA. So we should, if you assume that this one is S1 and this one is S0, with this only the answer is going to match. And now you can do it repeatedly, what is the output is going to be here. Okay, so what did you give? AB plus B bar C. AB plus B bar C. So he is asking which of the option is going to be correct one for these inputs D0, D1, D2, D3. I think this is going to be a routine one, we have to do it here. So take AB as selection line, we can do it like this. F equal to A bar B bar into something, A bar B into something, A B bar into something, A B into something, that's it. So convert this equation into this form, then you will come to know what are the inputs here. For example, this equation I will convert it like this, F equal to, last one I am going to write ABC bar plus ABC, and this one A bar B bar C plus A B bar C. So take them from this one, substitute the inputs into this. A bar B bar into C. So map it here. Next A B bar into something. So here you have A B bar C. Next A B into C bar plus C, and here it is 0. So the I0 to I3 connections are C, 0, C, 1. So the correct option to this is this one, C0, C1, D is the right answer to this. But you have to understand that B is taken as S1 here, A is taken as S0. With that adaptation, it comes like this. Fine, this is regarding logic families. It is memory based question. We have seen all the logic families, what is its performance, what are the merits and demerits. So in this one is asking which of them is going to have worse noise immunity and more power dissipation. So we know that in ECL, noise margin is 0.3 volts and more power dissipation. The reason is the transistors will operate in active region here, they are not going to operate in saturation. So because of the operating in active region, the power consumption is going to increase in this logic family. So the correct option is this, ECL. Fine. So the next one is successive approximation ADC. Right. He told that reference voltage is 512 millivolts and given input is 491 millivolts. Okay. And then what is the digital output I am going to get for this one? If you do it traditionally, it may consume some time, so we can go ahead with the shortcut like this. Find out the step size. So in this, the resolution is equal to, it is nothing but, what is the reference voltage he has given? 512. 512 by 2 power 8, that is equal to 2 millivolts. Okay. So 512 millivolts by 2 power 8, that is going to be 2 millivolts. So let's find out what the difference between the two. VR minus Vin, it is going to come as 1, 2. Okay. That is nothing but 21. Yeah, 12 plus 9, 21 millivolts. So divide this by 2, it's going to come to, that is going to be 21, 1 minute. Okay. So what is the reference voltage is given? 512 millivolts. Here 8 plus 2, 10, right. So it is around 21 millivolts. So 21 divided by 2, it's going to come as 10, approximately 10. So the output is going to be maximum value minus 10, that is 255 minus 10, that is going to be 245. So that's nothing but 244 approximately. So that's output is going to be this. 4 ones 0 1 0 1. It is nothing but 255 minus 10, that is going to be equal to 245. So you can do it traditionally or else you can do it in this fashion. Find out the resolution of the ADC and then how much difference is there between reference voltage and 491 millivolts input given, and this divided by step size is going to give how much count that will be less than the maximum. This is the maximum output you can get, minus 10, that is 245. This is going to be approximately 11110101. So the correct option to this is B. So thank you, and these are the solutions. For detailed solution, please look into the website. Now I request my colleague to carry forward.
Yeah, hi dear students, a very good evening. I hope you gave up excellent this engineering services 2024. So let us check it out, some important questions what we got today in basic electronics engineering, which is devices, electronic devices. Let us go to very first question, guys. So in a MOS transistor, the depletion region width D, okay, depletion region in a MOS transistor commonly universally So universally, we represent with XD, correct or not? Depletion width in a MOS transistor. The notation what we follow is XD. So for a junction, okay, depletion width is asking, and epsilon for silicon, epsilon naught, and V is nothing but effective voltage. Commonly, effective voltage we denote with a Xi silicon, correct or not? In our MOS designs, we commonly represent with a Xi silicon. Okay, N is a doping level, so it may be a P-type substrate or N-type substrate. Universally, he has given N. So what will be the formula here? Commonly, we go for the step graded. So XT is equals to 2 epsilon by Q into 1 by doping into Xi silicon, correct or not? Which is none other than 2 epsilon by Q into 1 by N into voltage. That's it. So 2 epsilon, epsilon can be represented in this way, 2 times epsilon naught, epsilon, I mean to say R of silicon, correct or not? Epsilon naught, epsilon R into V whole divided by Q times N. Yes, so 2 times epsilon naught, epsilon silicon into V by Q times N. So option A is apt for the given question. Correct or not, dear students, right? Now go to the next question. Consider the following statements regarding the bipolar junction transistor and the field effect transistor. What we know, students, if you go with a BJT, BJT is a current control device, correct or not? Whereas field effect transistor is nothing but a voltage control device. And the BJT default property is a current amplification factor. BJT default property is what, dear students? Current amplification factor. That means output current depends on input current. Current control device and current amplification factor is a default property. Whereas field effect transistor, default property is a transconductance. The default property is what, dear students? Transconductance. That's why FET is called as a transconductance device. So output current depends on input voltage. Transconductance indicates what? Output current depends on input voltage. Now check it out the options what they have given. Excuse me. BJT is a voltage control device. Here itself it is wrong option, because BJT is what here? Current control device. So absolutely it is wrong. Field effect transistor is voltage control device, whereas BJT is a current control device. So here in both BJT and FET, the output current is controlled variable. Yes, that's right. So output current is variable, it controlled variable, and that means a dependent variable, correct or not? So current controlled current source, it is what here? Voltage controlled current source, right? So controlled variable is apt, and due to high input characteristics of FET, that means high input impedance of FET, the AC equivalent model is somewhat complex than, so I think it is wrong, absolutely. Absolutely it is wrong. Why? Because the AC equivalent circuit of field effect transistor is very easiest way of design compared to the BJT. So due to high input characteristics of FET, the AC equivalent model is somewhat complex. No, that is impossible. So what is the question he is asking? Which of the following above statements not correct? Okay, not correct. Then this is correct, but they are asking not correct. So 1 and 3 are not correct. So 1 and 3. So option C is apt for the given question. 1 and 3 is not correct. Now let's go with another question. So check it out here. Consider the following statements regarding the semiconductor diode. So yes, this is very interesting way of asking question, guys. Semiconductor diode, you know, the peak inverse voltage, I hope you know, silicon will support high temperature capability. Silicon can support high temperatures. Germanium cannot support high temperatures. Have you remembered or not? Wider the energy gap, higher will be the temperature handling capability. Correct or not, dear students? So peak inverse voltage for silicon, commonly it is in the range of around 1000 volt. Whereas peak inverse voltage for germanium, so this is for silicon, peak inverse voltage for germanium, it is common in the range of 400 volt, 500 volt, in that range, commonly 400, 500 volt in that range. Whereas for silicon, it is around 1000, 1100 volt, commonly in that range. Okay, so the peak inverse voltage, I mean to say the rating, yes, because maximum reverse bias, reverse voltage dropped across a diode without making any damage to the diode is the peak inverse voltage. This is right, this is right. So this is absolutely right. For silicon, it is almost like 1000 volt. Whereas maximum peak inverse voltage, okay, for germanium is 200. No, because a common peak inverse voltage rating for germanium is in the range of around 400 to 500 volt, in that range. But here the maximum voltage is showing it as a 200, which is not correct. Okay. Germanium can be used for applications in which the temperature may rise to about 200 degrees centigrade. I'm sorry to say this, guys. You know, my dear boys and girls, have you remembered or not, critical temperature or a Curie temperature discussed in the class. What is the Curie temperature? So the maximum temperature after which my silicon or a germanium may behave like intrinsic semiconductor. Extrinsic semiconductor behaves like intrinsic semiconductor. For germanium, the maximum operating temperature is advisable in the range of 85 degrees centigrade to 100 degrees centigrade. This is the common range for germanium, the highest operation, I can say, the temperature. Okay, more than that, not advisable. By that, extrinsic semiconductor may behave like intrinsic. Whereas in case of silicon, it is almost like a 200 degrees centigrade because it will support more temperatures. So here, germanium can support 200 degrees centigrade, which is highly impossible. Silicon can support, not germanium. So this option, I mean to say, this third point is absolutely wrong. Now what exactly they're asking, guys? Consider the following statements. So which of the above statements are not correct? Not correct. So first one is correct, second and third both are not correct. So 2 and 3 only is apt for the given question. That is option C is absolutely right. Now check it out. Consider the following statements regarding a semiconductor diode. Once again, asking about a semiconductor diode, guys. You please check it out. AC or a dynamic resistance. Yes, you know RAC of a diode. RAC, or we say R dynamic, or simply I can say small signal resistance. What is that value? VT by IDQ, where ID is nothing but a diode current which is under quiescent point. So at 300 Kelvin, it is 26 millivolt. So 26 millivolt by IDQ, yes, this is correct. Yeah, so this would be correct. Whereas the lower the quiescent point of operation, lower will be AC resistance. Excuse me, you please check it out here. AC resistance inversely proportional to the Q point, diode Q point. So if Q point, that means the diode current is small, the resistance must be large. If the quiescent point current is a smaller value, the resistance must be large. But examiner, he is asking, the lower the Q point of operation, the lower will be resistance, which is absolutely wrong, man. This is wrong. Excuse me, correct term, that is wrong. Whereas, as with the DC and AC resistance levels, the lower the level of currents used to determine the average resistance, the higher will be the resistance. Absolutely right. So the currents which are propagating in the device, which is nothing but a quiescent point current, if current is smaller, the average resistance absolutely must be larger. So option, I mean to say this third point is apt. Now which of the above statements are correct? Now you please tell me, guys. I think first one and third one, first and third. Yes, first and third are apt for the given question. So option B is apt for the given question. Yes, okay. Now check it out the next question. Consider the following statements regarding the bipolar junction transistor. Very interesting. So check it out here. Beta decreases with the decrease in the temperature. I'm sorry to say that, you know, decrease in the temperature. Beta decreases with the decrease in temperature. That means, I think you know that at low temperatures, beta is almost maintained constant. Correct or not, dear students? At smaller temperatures, beta is almost maintained constant. If the temperatures are getting increased, then there will be change in the beta value. So this is okay. So this is absolutely wrong, okay? And VBE decreases about, I think you know, VBE is nothing but what here? Diode voltage. Diode voltage is almost equal to built-in voltage. I think you know, built-in voltage decreases with increase in temperature. How much, guys? Built-in voltage decreases. That means dVBI by dt is how much? Is around minus 2.5 millivolt per degree centigrade is correct. Therefore, VBE decreases about 2.5 millivolt per degree centigrade. That is absolutely right. So this is true. This is true. What is the third point? Reverse saturation current doubles for every 20 degrees. I'm sorry to say that. I hope you remember this formula. I02 is equals to I01 into 2 power T2 minus T1 by 10. That means what? Reverse saturation current doubles for every 10 degrees centigrade increase in temperature, not 20 degrees centigrade. So this is absolutely wrong. Now what exactly they're asking, guys? Which of the following statements are not correct? Yes, first one is not correct, third one is not correct. So 1 and 3 is apt for the given question. Guys, understanding also option C is correct. Now, I think the question is not clear. So if I'm not wrong, they're asking a transistor with alpha. I'm sorry, let me change the color. Yes. So a transistor with alpha, I think I must be having this question. Yes, alpha, they have given us 0.98, which is nothing but alpha forward current gain of common base. And they have given ICBO. So ICBO is around 5 microampere they have given, okay? And IBQ, that is the quiescent point of the base current, IBQ is around 100 microampere, okay? Now examiner is asking to find the value of ICEO. I think students who gave up this exam, you please check it out. I think this must be correct for the given data, okay? So anyways, they're asking to find the value of ICEO. Excuse me, you know the formula. What is ICEO, guys? ICEO is equals to 1 plus beta F times ICBO. Correct or not, dear students? What is 1 plus beta? I could represent this as 1 by 1 minus alpha into ICBO. So it is like 1 by 1 minus, what is alpha F? 0.98 into what is ICBO, guys? 5 microampere. So if you could solve, you'll be getting almost like a 0.25 milliampere. That's it. So 0.25 milliampere. So 0.25, I think option A is apt for the given numerical. Let me check it out another question, guys. So consider the following statements regarding the common collector configuration. Okay. So the common collector configuration is used primarily for impedance matching purpose. This is absolute, because it's a voltage buffer, correct or not? So perfectly used for impedance matching. Common collector is nothing but emitter follower, right? So it has a high input impedance and a low output impedance. That is right. Common collector or emitter follower is having high input impedance and a low output impedance. Yes, this is correct. Which is exactly opposite to the common base. That is perfect, guys. So a common collector circuit provided with the load resistor connected emitter. Yes, that's right, because output is taken across emitter. I repeat, in a common collector, it is nothing but emitter follower. Output is taken across emitter with respect to the ground. So this is correct. So 1, 2, 3. Which of the following statements are correct? Yes, 1, 2, 3. I think option D. Option D is apt for the given question. Option D is apt for the given question. Option D. Okay, guys. Option D is apt for the given question. Check it out one more interesting question. So, guys, IDSS is the maximum drain current for a JFET and is defined as IDSS. I hope you know this formula. ID is equals to IDSS. Let me take N channel JFET, okay? IDSS into, speak out, guys, 1 minus VGS by VP whole square. Here VP is nothing but what, dear students? VGS off. Now speak out, guys. So at VGS equals to 0, please tell me at VGS equals to 0. Now speak out, substitute at VGS is equals to 0, no doubt. ID will be IDSS, this is apt. At VGS is equals to 0, ID is equal to IDSS is apt. Not only that, you know, if I draw the output characteristics, let me say this is N channel, VDS and ID. So let me put a VGS as constant. That means at some particular voltage, VGS as constant. What is this voltage, guys? This is nothing but what, dear students? This is, I mean to say pinch off voltage, correct or not, dear students? This is nothing but what, dear? Pinch off voltage, output pinch off voltage, it is almost. Now speak out, guys. After this only, I can get the saturation value. Saturation value. So if I want to use this expression, which is under saturation, condition is what, dear students? Condition is what? VDS must be greater than VP. That is perfect. And VGS is equals to 0. VDS greater than VP. So VDS greater than VP. It is under saturation region. Then I can use this formula and substitute VGS equal to 0. If I substitute VGS equals to 0, then ID becomes IDSS. I think that's what he's asking. What are the condition to get a drain current, quiescent point current is equal to IDSS? This is apt. Therefore, option A, I'm sorry, not option A, option B. Option B is apt for the given question. VDS greater than VP and VGS must be equal to 0. So like that, guys, most of the questions I hope I have discussed for today's paper, and my colleague will be continued. And for detailed solutions, you please visit the website of ESE Engineering Academy as well as ESE Online. Best wishes, guys.
7 అంతే ఏ 5 నిమిషం. Hi students, welcome back. I'll going to deal with the questions which are related to the electromagnetic theory. As usual, there is a sizable number of questions was asked and the very good weightage for this subject. Okay, so let us deal with the subject as usual. So there is some controversy with the questions. Some questions are not properly framed. That remains the same in every paper. Fine. So here is a question. It is a very straightforward. The international system of units SI, Q1 and Q2 are expressed in coulombs. R is the distance in meters, the force in newtons. So if there are two charges here according to the Coulomb's law, here it is a Q1, here it is a Q2, and the distance between them is R, the force is equal to 1 divided by 4 pi epsilon naught into Q1 Q2 divided by R square. So this part is nothing but a K, which is equal to 1 by 4 pi epsilon naught, whose value is equal to, you can check out, it is 1 by 4 pi, 36 pi. So it is 9 into 10 to the power of 9. This is Farad per meter. Now it is reverse, it is meter per farad. It is a very straightforward, it is 9 into 10 to the power of 9 meter per farad is the answer. Next. Yes. So here is the theoretical question. One should carefully, there is a possibility of ambiguity, there is a possibility of discussion, debate over these kind of questions. Fine. So let us try to give the best possible answer for this. So which of the following does not indicate the space perceiveness of electromagnetic effects? So this is something related to the electromagnetic fields involved with the space. Fine. Okay, let us focus on the first one. The presence of the current in the two circuits in the proximity to each other. The presence of current in the two circuit proximity to each other accompanied by the electrical forces. See, when there is an electric field, when the current flow is happening in one of the coil, it is surrounded by the magnetic forces, not the electric forces. He said what is called electrical forces. So I would say this is a wrong one. So according to the question, this is not the correct one. This is not the, this statement is wrong one and this is the answer. Let us check why, let us try to convince why other options are correct. Fine. So the changing of the current in the either of the two such circuits is accompanied by the induced voltage in other. Okay. So when there is a change of current in one coil, that leads to what is called a time varying magnetic field around it, that will obviously going to induce the magnetic field in the other coil. So the second statement is correct. Third one, the capacitor consisting of the metallic spheres of the other conducting bodies suspended in the vacuum or in a insulating medium may be charged and later discharged. During this process, wire-borne current flows onto one sphere after the other. So you would have seen these kind of videos in the YouTube where the two charged bodies, if you brought together, there is a possibility for the spark between them that leads to what is called a flow of charge from one sphere to the other sphere. That is nothing but a flow of current. Fine. So this is also true. The fourth one is the presence of electric charges on the two bodies is accompanied by the mechanical force on each other. The forces which change if the charge is changed. Obviously, if the charge is changed, that leads to the force of, that leads to the change of electrical force between the two charges. So this is also correct. So the best possible answer is option A is the answer. Fine. Next. Which of the following points is related to the pointing theorem? So pointing theorem, let me write down the pointing theorem expression here. So there is a very big expression. It is, this was proposed by the, this was proved by the Coulomb himself. Closed surface integral of E dot dA, which is equal to minus volume integral of sigma into E magnitude square into dV minus volume integral of, you can, I'll continue here, just I'll strike it off this. So it is a volume integral of dou by dou t of 1 by 2 into mu h magnitude square plus 1 by 2 into epsilon into E magnitude square into dV. Fine. So you can have an interpretation of each and every word here. I will not go into the details of that, but to put it in simple words, this is corresponding to the loss in the medium, and this is the storage of the electric field, power density in the electric field as well as in the magnetic field. So if the power density is coming out of any closed surface, which is comprises of loss as well as the energy storage in the electric field as well as in the magnetic field. Okay. So this is the base to answer this question. Now let us focus on the options here. So the variations in the time of a in term corresponding to the sum of energies associated to the electric and magnetic fields and stored along the line. Yes, these are correct. So it's talking the same pointing power flow with respect to the line. Line here is a transmission line. So it's talking the power flow, electromagnetic wave with respect to the guided medium. Fine. That point need to be noticed here. The other one, power dissipated along the line due to the Joule effect. eating effect, Joule effect or dissipation one would say in the conductors, and the losses in the dielectric. Yes, the losses in the dielectric. You can check out this expression. This expression will be talking only about the energy stored in the electric field, energy stored in the magnetic field, as well as in the dissipation in the conducting medium. But this expression do not incorporate the losses offered by the dielectric medium. And one can say that the losses offered by the dielectric medium can also be included in this term, Joule effect itself. That do not describe separately. Okay. So the more appropriate answer would be option B is the wrong one. So according to the question, this would be the answer, option B. Let us try to convince you why other things are wrong. Fine. So the flux in the sense here, a quantity which is crossing some surface is called a flux. It could be electric flux or magnetic flux, and even power can also be called flux. The flux of the Poynting vector is coming out from the ends of the line. So this is a power entering this is a power leaving after traveling the distance of d. This is a power and density entering. So at a distance of 0. So this you can call it as a flux, net flux. So this is also correct. Next, last one. The theorem is not applicable to the more general case of the transmission lines with the frequency dependent parameters. See here, this is a general expression. This is valid for any medium, any structure. Fine. So there is nothing like a limitation on the frequency of operation. Fine. So this is a statement correct one. So the wrong one would be option B, and this is the answer. Fine. So let us try to deal with the other question. There is some information is missing here. He may be, I don't know how he has collected from where he has collected this question. Why? Because the data given is incomplete. I do not comment anything on this one. Why? Because see, which of the following is not applicable channel guides? Okay, fine. One thing is he must have mentioned what kind of channel guide is this. Is it talking about the fiber optic cable or a waveguide, or what kind of structure is this? And other thing is he has not given any diagram for the channel guide. See here, it is the x dimension. Did he given, no extra information is given in the question except this x direction. The other one is, it is confinement of the light within the film plane, that is YZ plane. No. So YZ plane is also not mentioned. So I would not comment anything on this one. So I will not say anything. Now let us, yes. So it is a numerical type of question, yes. Check out what is the radiation resistance of the infinitesimal dipole whose overall length, the length of the dipole is lambda by 50. So it is a Hertz dipole. What is the radiation resistance? Radiation resistance is equal to 80 pi square dl by lambda whole square. So it is 80 pi square. What is this dl? dl is equal to lambda by 50 by lambda whole square. So which is equal to 80 pi square divided by 50 square. So what is the radiation resistance? You can check out, do this calculation. This is approximately 0.316 ohms. Fine. Okay. So the option A is the answer. Next. Yes. So let us try to extract the best possible answer for this. So one can debate and discuss, make a discussion about the different options here. See, when two antennas are near to each other, some energy that is primarily intended for one ends up at the other. So if there is a communication is happening between the two antennas, then what would be the communication between these two antennas will going to be affected off. Fine. So the amount does not depend on, it does not depend on what? See, if the communication is happening between the two antennas, it refers to how these two antennas are oriented to each other. They must orient in a maximum possible direction. Fine. So what I will say, the best possible answer is option A. The radiation characteristics of each single antenna radiation characteristic will not going to affect the communication between the two antennas. The communication between the two antennas will going to depend on the characteristics of the two antennas, not a single one. Fine. So let us try to answer why this is correct. Relative separation between them. Yes, obviously. So how far, what is the distance between the two antennas will going to affect the communication between them. This is a correct statement. The relative orientation of each. Yes. Relative orientation, how these two antennas are oriented with each other. Yes, this is also correct statement. A mutual coupling between them, how they are coupled. Yes, this is also. So the most appropriate answer is option A is the answer. Fine. So let us have one more. Yes, you can check it out here with some simple cavity backed printed antennas will going to support what is called a narrow band. And microstrip antennas and waveguides will be coupling inside the structure. If you know this one, see how the coupling happens for the waveguide. They will make a hole on the top, or at the center they will going to feed the signal. Fine. So you can say that R is equal to 4. R 4. So it is 52. Yes, option A is the answer. 52, option A is the answer. The remaining things you can just join the things here. Next. Okay friends, so there is again one more issue with this question. See how they have formed the question. See, it is in front of you. Option B and option D, you can see the same thing. Okay, you would have done some mistake while copying the questions from his source. Fine. So quite funny thing about this question preparation. If the permeability is larger, then the skin depth is smaller. See, this option, both are same. Anyhow, friends. So what is the skin depth beta? Which one of the following properties is not correct for the skin depth? What is the skin depth? Skin depth is equal to 1 by alpha, which is equal to square root of 2 by omega mu sigma. Yes, fine. So if the frequency is higher, then the skin depth is smaller. He said which is yes, the frequency increases, skin depth will going to fall. So this is correct. Option B, if the permeability is larger, then the skin depth is smaller. If the permeability is larger, skin depth is smaller. Yes, this is correct. Option B is correct. Option C, if the conductivity is larger, if it is larger, then the skin depth is smaller. This is also correct. If the permeability, same option got repeated. So I would not say anything about this. I leave to the examiner. Next. A slot antennas of the dual monopole fleets has, yes, there is some ambiguity this one. So I would suggest the more appropriate answer would be option C. Fine. Consider the following statement regarding the antennas. Yes, it is all about what is called a end fire array and broadside array. Fine. Just read out here. The broadside array, suppose if you take the set of antennas which are called array, this is called the axis of the array, this is a perpendicular to the axis of the array. Broadside array has its maximum. Broadside array has its maximum radiated along the axis of the array. Wrong. Yes, the end fire will have axis. End fire array has its maximum radiation directed along the axis of the array. Yes, this is a correct statement. Third one, the resultant pattern for an array which is known as a pattern multiplication is a product of the unit pattern and group pattern. Yes, the resultant radiation pattern, that means when you have the set of antennas, the resultant radiation pattern would be a group pattern into individual pattern. Fine. So this is a correct statement. So the second one and third one, option, this one better. This one, oh sorry, let me go back. Yes, option, not this one, option B, C, option C is the answer. Next, so it is not clearly visible, but see here, is asking the work done. Yes, so what is the work done? Work done is equal to minus integral of E dot dl, Q into E dot dl. Yes, is asking for the work done from initial to final point. So what is the, you can check out here, it is 1, 0, 0, this is 2, 1, 3. So how much is the charge here? The charge here is how much? It is not 2 coulombs. Integral is from E dot dl. What is the E? It is the y x cap plus, let me write down, it is y x cap plus x y cap x cap. Just a second. Okay, there was some technical issue. Let us focus here. A non-uniform electric field is given by E is equal to yx cap plus xy cap plus 2yz cap volt per meter. The charge of 2 coulombs is transferred from a point 1, 0, 0 to 2, 1, 3 along the straight line from the A to B. What is the work done? Fine. So work done expression you can check out here. The work done is equal to minus initial to final E dot dl. Yes. So what is the charge here? 2 coulombs. So initial to final. So it is y x cap plus x y cap plus 2y x cap, 2y z cap, dot product with dx x cap plus dy y cap plus dz z cap. I will skip some of the steps here. You can notice that z component is constant. If z component is constant, dz is 0. So this part is 0. Fine. So it is minus 2. Fine. So it is y dx plus x dy. So from your integration knowledge, you can write this one as an integral factor. Fine. So the 2 minus 2 into x y. You can check out here upper limit minus lower limit minus 2 into, what is upper limit? The upper limit is 2 comma, it is 2 into 1 minus, fine. So the lower limit is 1 into 0. So which is minus 4 joules is the answer. Okay friends, so what is the answer? Minus 4 joules. Option D is the answer. Next, it is a direct straightforward differential magnetic field at any point proportional to the current, and this is all defined by what is called Biot-Savart's law. It is analogous to what is called a Coulomb's law. In the Coulomb's law, electric field will be described here, Biot-Savart's law. Next, yes, so you can take this as a EDC question. The only thing is he has placed what is called a unit vector. Fine. So the base, it is a very fundamental question. So what is this VD? VD is equal to mu into E. Some will say minus mu into E. Yes. Okay. This is a vector form. So what is this mu? Mu into electron, charge of electron into total mean time period by mass. Fine. So substitute all the values here. He has not mentioned actually unit vector. In all options, unit vector he has considered to be Z. So I'll also consider that one. So just substitute here, charge of electron is 1.6 into 10 to the power of minus 19 into mean time is given. How much is the mean time? Mean time is 2.7 into 10 to the power of minus 4, and this one mass of the electron is 1.9 into 10 to the power of, you can check out here, 10 to the power of minus 31. And one more thing, electric field is not mentioned here, but the potential is mentioned. So the potential is equal to, electric field is equal to potential by a distance. How much is the potential? 10 divided by the distance of the length of the copper wire is 2 meters. Fine. So and add that, make that one as a unit vector according to the question. So I will take it as a unit vector. Check out. This will turn out to be 23.74 into 10 to the power of minus 3 z cap or az cap meter per second. Okay. So this is all about the questions which are related to. There are some ambiguity. I do accept. I don't know how from he has prepared some questions from the nook and corner of your syllabus. There are some questions who are not properly framed. Fine. So if possible, we'll come out with some more detailed solution for them in the coming days. Fine. Hope you people have done well. I'll hand over the session to the other panel member. Thank you. Good luck.
Right, I am here. I am going to discuss questions related to the material science. Now the question here, it is a very simple question. The crystal structure of titanium metal. Titanium metal is hexagonal close packed structure. So C is the correct answer. Next, manganese oxide is what type of magnetic material? Manganese oxide is anti-ferromagnetic material. So B is the correct answer for this question. Very simple question. Next, consider the following statements. The coordination number and atomic packing factor of hexagonal close packed crystal structures are less than the body centered cubic structure. See, hexagonal close packed crystal structure atomic packing factor 0.74, coordination number 12. Right. BCC atomic packing factor 0.68, coordination number is only 8. So this is not correct. Next, the coordination number of the atomic packing factor of the hexagonal close packed structure are greater than the face-centered cubic structure. Face-centered cubic structure also atomic packing factor 0.74, coordination number 12. So, atomic packing factor and coordination number of HCP and face-centered cubic structure both are same, equal. That's why only third statement is correct. Remaining two statements are not correct, and in the question here not is given. That's why 1 and 2 are the correct answer. So, B is the correct option for this question. Very simple question. Now, the equilibrium number of vacancies for a given quantity of material. See, number of vacancies are increases exponentially with increasing temperature. So, B is the correct answer. Number of vacancies is equal to n into e power minus ev by 3 kt. So, increases with increasing exponentially. So, B is the correct answer for this question. Next, silicon dioxide is a zinc blende structure. So, C is the correct answer for this question, zinc blende structure. Right. So, composite material list 1 and list 2 is given. Particle reinforced composite is comes under dispersion, and fiber reinforced composite comes under discontinuous, and structural composite comes under laminate. So, 2, 3, 1 is the correct answer. So, C is the correct answer for this question. So, here C is the answer. Next, another question match the following: silicon, molybdenum and cobalt, ferromagnetic, diamagnetic and paramagnetic is given. Silicon is a diamagnetic material, molybdenum is a paramagnetic material, cobalt is a ferromagnetic material. So, 2, 3, 4, 2, 3, 1 is the correct answer. So, B is the correct answer for this question. Right? B is the answer. So, these are the questions from material science. Next, our colleague faculty will continue.
Right. Hi everyone. I am going to discuss the questions from electrical measurements or electronic measurements. From this, measurements questions will be there as well as transducer questions will be there. Now I am going to discuss about the key, and you can go through all the detailed solution by tomorrow from our website. Here the first question is, this is the question related to LVDT, right? Which of the following statements, consider the following statements which are not correct here is given. So LVDT which are not correct means answer here is 1 and 2. These two are not correct, right? Option A. And this is the question related to thermometer. This is a question related to thermometer, and he has given that in case of system failure, usually the entire unit needs to be replaced. Capillary allows considerable separation between the point of measurement and the point of indication. Complex design makes them expensive. Right? Which of the following statements are correct here is given. Right? For this question, it's option D is the answer. 1, 2, 3, all are correct. All questions are theoretical questions only, so all are correct. Next one is, consider the statements regarding the transducer and which of the above statements are correct. Again he is asking which of the above statements are correct. Here, eddy current gauge is used to measure displacement, right? This is correct. Pirani gauge is used for high pressure, this is wrong. And right, Wiedemann effect is used in transducer to measure the torque force displacement, it is also correct. So therefore 1 and 3 are correct. So therefore option here is, right, B option, 1 and 3 only. And consider the following statements regarding electromagnetic flow meter. It is also a theoretical question. Here given some questions and some statements which are not correct. He has given which are not correct. So for this 2 and 3 are not correct. This and this both are not correct. He is asking not correct. So therefore answer here is D. Consider the following statements regarding the vibrating element pressure transducer. Vibrating element pressure transducer. Here whatever the statements are given, all are correct. 1, 2, 3 are correct. All these are the theoretical one. These are the standard values. So option here is all are correct. And the mean time between, right? Here a potentiometer is used to measure the displacement of corresponding hydraulic, right? The potentiometer is 25 centimeter long, has a total resistance of 2500 ohm and is operating 440 watts voltage source. If it has linear resistance displacement characteristics, then the sensitivity of the potentiometer. And what he is asking here, volt per centimeter. If you follow the units, answer will be very simple. Volt per centimeter. Sir, centimeter is given. Watts is there, resistance is there. So therefore P is equal to V square by R. Power is there, resistance is there. From this you can calculate voltage equal to, right, you will be getting 100 volt here. And he is asking volt per centimeter. So simply sensitivity equal to 100 volt per 25 centimeters. So obviously 4 volt per centimeter. So answer here is option B. Right. Next one, it is also a theoretical question, right? Consider the following statements regarding measurement system, right? And then here the dead zone in a pyrometer is, dead zone is given, that is 0.125%. The dead zone in a pyrometer is 0.125% of the span. Nothing but this is the span, 0.125% of the span. And the instrument is calibrated from 800 degrees centigrade to 1800 degrees centigrade. What is the value of temperature below which no change can be detected? See, this type of model, same model question we have done in the class also. No change can be detected. So indirectly he is asking dead zone only, but he has given in terms of percentage with span. So simply, what is the span here? The span here is 1800 minus 800. So therefore the span here is 1000 and 0.125%, 0.125 by 100 into 1000, right? So you will be getting the value as 1.25 degrees centigrade. Yes, option C is the answer. And the next question here is, this is related to again measurement theoretical question, and in this Consider the following statements regarding the measurement system. Three statements are given which are correct. See here, if a known voltage is 200 and these are the values he has given, accuracy is about 1.25, means error is given as 1.25. Sir, this is a true value, for example, and by taking average value, that is mean value of all this, you will be getting the measured value, or based on these to find out the error. This error will be coming around 2%, but he has given 1.5, therefore this statement is wrong. And here accuracy, precision and calibration. So this is a standard value, accuracy is equal to precision plus calibration, it is correct. And this statement is also correct, so answer here is D option, that is 2 and 3 are correct. And next one is, this is related to hygrometer, Again theoretical question here, these two statements are correct and this is wrong, so therefore answer here is 1 and 2 are correct, that is option C, 1 and 2 are correct. And in this is 1 or 2 question and here, what is the percentage error in the measurement of kinetic energy of a body if the percentage error in the measurement of mass is very simple? Kinetic energy formula, basic formula, half mv square, for example. He has given error in mass, error in velocity or speed. So error in mass is 2%, error in velocity, that is speed, is 3% square. So therefore 2% and 3% square, 2 into 3. So we can write directly 2 into 6. So multiplication operation is there, percentage errors must be added. So therefore plus or minus 8%. So therefore 8%. But by the confusion you may multiply 6 into 2, 12. No, this is errors must be added. So therefore answer here is 8%. And here this is somewhat lengthy question, but this is a basic equation based on the standard deviation method. Here 10 kg is given, he has given as error. So therefore 9.95 to 10.05. If you use this entire thing and substitute and expand, you will be getting the answer as 0.06. So these are the questions from the measurement subject. After that, I only will be discussing basic electrical engineering questions. Right. Now let us see the questions from basic electrical engineering. Here the first question is, right, based on the machine windings they have given. First question is induction machine. In the induction machine, right, field winding is placed on the stator and the armature winding is on the rotor. First of all, in the induction motor, there is no notation of field winding at all. So therefore this is wrong. In DC machine, the stator winding serves as both armature winding and field winding. It is also wrong. If it is there, commutator action will be failed. And in the synchronous machine, yes, both are possible. He has given rotor carries field winding, correct only, and stator carries armature winding. So therefore correct. So therefore only 3 is the answer. Right. Next question is, this is a direct answer here. The conversion efficiency of fuel cells approximately is 70%. This is a general out of syllabus, we can say 70% is the answer. And it is also somewhat small ambiguity is there. So he is asking like lamination of thickness lamination. Generally we say 0.232, 0.35 mm we can say. 0.23 or 0.21 approximately to 0.35. All options are there, so we cannot comment properly. And a relay which is used in oil immersed transformer protection against, right, kinds of faults. In the oil immersion, so basically we will be going for, what is it, Buchholz relay. So these are the questions from the basic electrical engineering. Next subject will be continued by other faculty.
very good evening, my dear students. I think with lot of patience you are waiting for network bit. Unfortunately or fortunately, I could say only 5 bits came, and relatively one of this was like a derivation, as numerical was not given. So you need some patience. What to do? Yes, IES is this, IES standard is this. Let us accept it. Okay? Yeah, we'll go with the first solution. Now this is a very interesting question. The capacitor in the figure is given below, which is initially uncharged, so no initial condition. The switch is moved from 1 for 5 milli. That means initially it was completely open. It came here to 1 position, but it stayed there for 5 milli, and then it came to position 2 after that 5th millisecond. Then the expression for current is asking. Now first of all, don't ever challenge current. My suggestion is don't ever challenge current, because in a state variable for capacitor is always voltage. So let us talk in terms of voltage. So better find voltage and then current, because I is CD. Unnecessarily current, I am telling you, you will get confused. So with respect to state variable voltage, this is like a step response first order. First initially this is not there because we are closing the switch at 1 position. So this is the voltage. So from 0 to 5 millisecond, if you take this expression, yes, V of t will be, what is V of 0? 0. Okay, first V of infinity will be what? 10. But it won't go there, you know. V of infinity will be initially 10 if you leave the switch here by turning on at 1 position. But you know, after 5th milli it will change. But the solution is valid only up to 5th milli. So V of infinity plus V of 0, 0 minus V of infinity e power minus t by tau. Okay, tau is how much? Yes, t by, if you take this as 1000 into this, 4 milli. Okay, so if you write neatly, this V of t is, this is 10 into 1 minus e power minus 250 t is the expression for voltage across capacitor from 0 to 5th milli. But now from 5th milli to infinity, yes, from 5th milli to infinity, okay, because it is further coming to position 2 and staying there forever. Now 5th milli to infinity, again the same expression, but here what is V of 0? Here V of 0 means V of t at 5th milli, V of t at 5th milli. So if you substitute here, that is 10 into 1 minus e power minus 250 into 5 milli, that is 1.25 you will get. Now this is a challenge in answer, calculating is a challenge. So if you do, yes, you will get this as something like, okay, yes, 7.13 volt, you will get 7. Now I will write the expression, this V of t for the second case, that means in this time, it is V of infinity, okay, V of infinity again is how much? If you leave at position 2, V of infinity become 30. So V of infinity plus V of 0, 7.13, because here V of 0 means voltage at 5th millisecond when the instant it is changed from position 1 to 2, minus V of infinity e power minus t by 2 minus 250 t. Yes or no? So if you simplify, you will get this as, finally you will get this as 30, okay, minus, okay, this is 22.87 e power minus 250 t. Okay, chalo, we got this. Then what about current? Now you will write this IC of t is C dV by dt. Now if you do that, this IC of t, what is C value he gave? C value is clearly how much? 4 micro. This is 4 micro into differentiation of this. Differentiation of constant is 0 minus that. That is 0 minus 22.87 e power minus 250 t into minus 250. Chalo, if you do that, yes, you will finally get this accurately as, yes, 22.86, okay, e power minus 250 t, okay, milliampere, because here micro is there, okay, here micro is there, and you convert into milli, you will get this. So 22.86 here. So option is clearly D, okay, option is D. So option is D, okay, option is D, not A please, okay, option is D. 22.86 e power minus 250 t milliampere. Okay, better go with voltage, otherwise unnecessary confusion and you will be tempted to write other answer, which I checked it already. Now see, for the 2-port network shown, yes, for the 2-port network shown, find the transfer impedance. Now generally everyone think that he is asking Z parameter Z21. Now that is a big difference. So many may think in Z parameter Z21, what is Z21? V2 by I1 when I2 is 0. That is not the meaning here. See, if you would have asked Z parameter, I2 would have been 0, then here no voltage will come. That is a ridiculous. So he is not asking that Z21 in Z parameter, he is asking the transfer impedance without that condition. So here we should not take I2 0. So in this case what to do? Chalo, if you do that, yes, if you see, everybody see, he is just asking Z21. What is Z21? V21 of V2 of S by I1 of S without any condition like I2 0. Normal Z parameter I2 0, here we should not take that, that is very important here. So what I will do, so if I write an equation here, just if I write an equation, see first if I do current division, everybody watch this, I will do current division. This I2 of S will be total current I1 of S into same by sum. What is same? Yes, this current is total current opposite by sum. Opposite is how much? S by 2 by sum. Sum is this. Current division rule, sir. S by 2 plus 3S plus 1 by 2S. Okay, this is first. So here transfer impedance, that is the term he is asking, not that open circuit transfer impedance. If you would have asked open circuit transfer impedance, then it is our Z parameter. Then make I2 0. That meaningless answer will come. There itself you should identify that is not being asked here. Just transfer impedance means that I2 should be there. Open circuit transfer impedance means I2 0, that is the Z parameter. That is the difference. Okay. So with I2 first I did current division, this total current I1 of S, current division, so I2 is total current into opposite by sum. Okay, that is what. Now what is V2? V2 is now V2. Now if you write V2, V2 is I2 into this. That I2 I can write in terms of I1. So but what is V2 of S? V2 of S is this I2 of S into 1 by CS, 1 by 2S. But what is I2? This is I1, this is only na. So if you substitute this here and this V1 by I2 if you take, yes, that Z21 of S, you will get this as, okay, you will get this as S by, okay, 14S square plus 2. Okay, you do that. See, because V2 is this, but what is I2? This is I2 now, you put here, okay, and then V by I is what is asking, you will get by S by 14S square plus 2. Okay, S by 14S square plus 2, option is C, option is C, option is C. Okay, see, don't worry with these tick marks. Actually, we got this paper from a student who wrote this exam, XYZ, don't worry, and maybe he would have marked it. We just copied and pasted and we are rich, so don't worry with this. This is the answer. Okay, S by 14S square plus 2. Okay, because we scanned it and we are teaching the solution as early as possible. Now let us go to, now this is one of the most challenging problem you can expect. It is like a derivation, sir, unfortunately. Now he is asking for the network shown, what is the voltage V of t across register? The switch closes at t equal to 0 and assume all initial conditions are 0. So here we know in Laplace transform, if you do, first find VO of S and VO of t will be inverse Laplace of VO of S. Now that is the challenge here. Now what I will do, see if you observe, I will do nodal analysis. First this will be L1S, L2S, 1 by CS, R, and I need the relation between VO and VS. VS is V and this is VO. So in less domain if I write, now let me take nodal, let this be V1 of S, let this be V of S, let this be VO of S. If I write the nodal equation KCL, this current, that is V1 of S minus V of S by SL1, this current, and this is V1 of S by 1 by CS plus this current, directly V1 of S by total path impedance SL2 plus R equal to 0. Now from this if you take V1 common, okay, V1 of S common, okay, you will get this as 1 by SL1 plus CS plus 1 by SL2 plus R, you will get SL2 plus R, and if you take this side, this is V of S by SL1, this part I am taking. So first I got V1, but what is VO? Voltage division rule, but VO of S is V1 of S total voltage, because this VO is total voltage, this branch voltage is this node voltage. VO of S is total voltage into same by sum. Same is what? R by sum. Sum is what? SL2 plus R. That is the second equation. This is the first equation, this is the second equation. But I want VO in terms of V. V is Vs. I want VO in terms of, so V1 is this by this now, so you substitute here. Chalo, if you substitute, yes everybody, if you substitute, okay, I am write them intermediate steps, you will get this as VO of S is equal to Vs into, okay, R, okay, this is R by, okay, R by, okay, SL2 plus R into 1 plus L1C S square plus L1S. But if you multiply, now this multiply and divide by CS. If you do that, finally you will get this as VO of S is, okay, Vs of S or V of S into this is R by CS by, if you do that, SL2 plus R, okay, SL2 plus R, this is 1 by SC plus SL1, okay, plus L1 by C, L1 by C. Okay, you will get something like this. And yes, finally, finally VO of t will be inverse Laplace of VO of S. Okay, VO of S, and if you do that, R by C, this you will get V of S, that is inverse Laplace of V of S, R by CS, remember. And if you take LCM further, yes, you will get this as, okay, inverse Laplace of this, and the option is A. Okay, if you do that, the option is A. Option is A. Maybe here the student gave the correct answer. Option is A. Okay, but it's like a lengthy derivation. This is one of the problem which really troubled most of the students. If numerical value would have been given, it is very straight. But writing this equation and writing in terms of first V1 by node voltage and then V. Then yes, this is out of all the bits, this is the most simplest bit. He is asking current I2. Okay, he is asking. What I will do, nodal analysis. If I take this as reference and let this be node voltage V, what is the node voltage? V minus 6 by 2. This is V minus 4 by 2. Okay, this is V minus of minus 2. V plus 2 by 4 equal to 0. Now, if you take LCM for 2V minus 12, 2V minus 8, okay, plus V plus 2 equal to 0. If you take this, total 5V equal to 18. Okay, so V is 18 by 5. But what is asking? He is asking current I2. Current I2 is going this way. Now I2 is 4 minus V by R2. I2 is 4 minus V by R2. That is nothing but 4 minus 18 by 5. Okay, by R2. R2 is 2. So finally you will get this as, yes, finally 2 by 10, 1 by 5, 0.2 amperes. 0.2 amperes. Option is C. Straightforward. Option is C. Okay. Yes, option is C. Now this bit, yes, I would like to consider into network theory. As no one was answering, I was very comfortable with this. A 10 volt 50 hertz sawtooth wave. What is the meaning of 10 volt 50 hertz? So you know the meaning of sawtooth wave. Okay. A 10 volt 50 hertz. That means it is a peak value 10 volt. Okay. 10 volt 50 hertz. So this is 10 volt 50 hertz. Now 50 hertz, what is the time period? Time period is 1 by 50, 20 millisecond. So this is 20 millisecond. This is 40 millisecond, like that. So a 10 volt 50 hertz sawtooth wave is pulse width modulated by 4 volt signal. Now you know, you give this to a comparator, sawtooth and DC, you give comparator, you will get pulse width modulation. But that pulse width is modulated by 4 volt signal. Now you take a DC 4 volt signal. Now if you take a DC 4 volt signal, yes, this is a DC 4 volt signal. Now by comparator you will get that. So whenever this sawtooth voltage is greater than this reference voltage, you will get output, pulse width. Okay, here. Now you know it is a linear function. For 20 milliseconds it is going 10 volts. So automatically for 4 volts it will take how much? 8 milliseconds. 8 milliseconds. So first of all, from the question, yes, from the question I can write that. Yes, from the question I can write that. Yes, what are the outputs of high time? Outputs of high time. See, how time will come at 8th milli. So high time will come at what? 8th millisecond. Yes or no? High time will come at 8th millisecond. That is where the output pulse will come. And the duty cycle. Duty cycle is this. So this by total. So the duty cycle delta is T on by T. T on by T. T on is how much? Yes, if you go with T on, that is nothing but 8 milli by total period. Total period is 20 milli. That is nothing but 40%. 40%. Okay, 40%. So high time occurs at 8 milli. Yes, and 40%. Okay, so 8 milli and 40%. Option is D. Okay, you can go with option D. So only 5 bits, and in that one is like a slightly derivation. So with this network theory, yes, unfortunate sir, but let us accept. Last year we got 22 bits, you remember? Okay, that's okay.